In our last video, we introduced the first form of a linear equation, the slope-intercept form. We said that the slope-intercept form was expressed as y minus y1 equal to m times the quantity x minus x1 for some slope m and some point that the line passes through, x1, y1. In this video, though, we'll explore a different form of a linear equation, namely the slope-intercept form. And kind of like the last one, where the name itself described the details of the equation, right? We had the point slope form because it displays a point that it passes through and the slope. This one is going to be really useful because it displays the slope and the intercept, as the name also suggests. And in particular, knowing the intercept and the slope is going to make this a really powerful form of a linear equation for us because it's going to allow us to quickly identify what it might look like on a graph. And we'll get to explore that in this video as well. And so first, what is the slope-intercept form? Well, the slope-intercept form of the equation of a non-vertical line with slope m and y-intercept 0, b is y equal to mx plus b. Again, where this m is representing the slope of our line and this b is representing the value of the y-intercept. Now, it's probably worth taking a quick recap here of what the y-intercept is. The y-intercept, which I'll just abbreviate as y-int, is just going to be the point where our function or our line intersects with the y-axis. So if we imagine a graph and we imagine a line, this point here is our y-intercept. And so having both of those pieces of information right from the equation itself is really, really powerful because the y-intercept sort of gives us an initial value, if you will, a starting place. We can lock that point onto the y-axis, and then the slope is sort of like our GPS. It tells us where to go from there. It is, after all, the rise over the run, so we'll know how much to go over relative to how much to go up or down. And so let's try that out with an example on a graph. If we're given a linear function in slope-intercept form, in other words, in the form of y is equal to mx plus b, then we can quickly identify a starting place and plot the y-intercept. So in this case, looking at this equation, we have y is equal to mx plus b. We can see that in this case, our value of b is equal to 1. And so the y-intercept is going to be the point 0, 1. And so we can plot that on our graph. We're going 0 left to right, so starting here, and then moving up 1 to plot our first point here. This is 0, 1. From here, we can use the slope as a sort of GPS to tell us where to go next. And so we'll use the rise over run to determine the next points. Now in this case, our slope is equal to -3/2, and so this is already written as a nice fraction for us, and so we can identify this as the rise over the run. And so the rise is -3, the run is 2, and so starting from that y-intercept point and treating this as a map, as directions, what this is telling us is to go right 2, right? We have a run of 2, so we go to the right by 2, and then a rise of -3, so down by 3, right? Down because it's negative. Or we could actually do the opposite of this and that would work as well, right? Instead of going to the right 2, which is our usual run, we could go in the opposite direction, right? And that would be left by 2, and in the opposite direction for our rise, which would be up by 3. And so starting at our y-intercept, we'll use these directions to tell us where our next point to plot will be. And so we'll walk over right 2, so that's 1, 2, and then down 3. And so that's 1, 2, 3. And we can plot our next point here. Now notice that these are labeled every half. So each of these lines represents a half. So this here is 1, this here is 2, right? This here is -1, this here is -2. So just make sure to pay attention to the scale and labels of your axes as you do this. But once you have this down, you can continue to follow this pattern to plot subsequent point after subsequent point. For instance, let's plot one more in the other direction. If we're starting from our y-intercept, we can then do the opposite of what our rise over run says. And so we can go to the left 2, 1, 2, and up by 3. So 1, 2, 3, and plot a point here, which you can see fits really nicely along this line. Now it only takes 2 points in order to graph a line, but it's sometimes helpful in order to draw it nicely to have 3. And so now that we have that, we can go ahead and draw a nice straight line connecting the 3 dots to represent our function f of x. And once you get a little bit of practice with this, it's going to be something that you can kind of get a quick intuition of just by looking at the equation, right? When we look at this equation and see a negative slope, that immediately tells us we're decreasing, and we see a y-intercept of 1, that tells us the starting place, and that doesn't give us everything super precise, but it does get us a good percentage of the way there, and at least understanding the general picture of what this graph is going to look like. And so with practice, you'll build some really good intuition to get a feel for what these lines are going to look like based on the slope-intercept form pretty quick. Lastly, you might be wondering, what if the slope is just a whole number? So what if m is a whole number? Right here it worked out really nice where the slope was already represented as a fraction, so we could identify the rise over the run. But what if it was the case, for example, that maybe m was equal to 4 and it was just a whole number? Well, in this case, it's important to remember that any whole number can also be represented as a fraction if we just divide it by 1. So this would tell us that m is equal to 4 over 1, and so we would have a rise of 4 and a run of 1. So we're going up 4 over 1. Hopefully this gives a sense of just how powerful the y equals mx plus b, or the slope-intercept form, can be, particularly when it comes to connecting what we see as an equation to a visualization on a graph and giving us that kind of intuitive understanding of what this line really represents in terms of a relationship between the quantity for x and the quantity for y. There is still other ways that we can represent linear equations though, and we'll see some of those coming up. So I'll see you in the next video, and I hope you have a great rest of your day.